In this example, I'm given three angles either in degrees or degrees and minutes, and I need to convert them all into radians. Well, what is the conversion factor that allows us to convert from degrees to radians? The conversion factor comes from the fact that one revolution equals 360 degrees, and it also equals 2 pi radians. And if I divide both sides of this equation by 2, I get my conversion factor of 180 degrees equals pi radian. Now in part A, I need to convert 220 degrees to exact radian measure. That means I need to leave the answer as a multiple of pi. So we take our given angle of 220 degrees, we turn it into a fraction by dividing it by 1. And now I'm going to use dimensional analysis, which says I'm going to multiply by a fraction. And I take my conversion factor and I put one side in the denominator and the other side in the numerator. How do you decide which one goes where? If I have degrees in the numerator, I must have degrees in the denominator, so they will reduce. So I have 180 degrees in the denominator, which leaves me with pi radians in the numerator. And now all I have to do is simplify this expression. My degrees reduce. If they hadn't have done, I would have done something wrong. And both of these numbers are divisible by 10. 10 divides into 220 22 times. 10 divides into 180 18 times. So it's going to give me 22 times pi, all divided by 18. Can I reduce my numbers anymore? Yes, they're both divisible by 2. 2 divides into 22 11 times. 2 divides into 18 9 times. So I have 11 pi over 9 radians. So that is the answer to part A. In part B, I need to convert negative 85.04 degrees to radian measure. But in this case, I need to round to 3 decimal places, so I know I'm going to need a calculator. So take your given angle of negative 85.04 degrees, turn it into a fraction by dividing it by 1, and now I'm going to multiply by the same conversion factor. I'm going to multiply by pi radians divided by 180 degrees. Now to simplify, my degrees reduce, and I get negative 85.04 times pi divided by 180. So now I need my calculator. I'm going to put the video on pause for a second. Here is my calculator. It's a TI-84 Plus Silver Edition. So I need to put this expression in the calculator. And sorry for my bad handwriting, that did say pi. So I'm going to put negative 85.04. So remember, this is negative, that's subtract. So negative 85.04 times pi. I need the accurate version of pi, which is in blue above the caret. So you hit second caret, and then finally divided by 180 and hit enter. So my answer is negative 1.4842, etc. I need to round to 3 decimal places. That's this position here. The 2 is not going to affect the 4. So my answer is negative 1.484 radians. And lastly, in part C, I need to convert 325 degrees 41 minutes to radian measure. Again, rounding to 3 decimal places. So the first thing I'm going to have to do is turn this angle into decimal degrees. And the way we do that is it becomes 325 degrees plus 41 minutes. We turn the 41 into a fraction by dividing it by 1, and then there are 60 minutes in a degree. I need minutes down here to reduce with those minutes, so I have 60 minutes is 1 degree. My minutes reduce, and so I'm going to get 325 plus 41 divided by 60. They're both in degrees. So that is my degree measure. I'm going to let the calculator turn that into decimal degrees. And then what I'm going to do is I'm going to multiply, just like before, my exact same conversion factor of pi radians divided by 180 degrees. My degrees reduce, and now I just have to put this expression into the calculator. What I mean by that is I'm going to use parentheses. I'll have 325 plus 41 divided by 60 times pi, and then I'm going to divide it by 180. So to do that, I must put this numerator here in parentheses. So I need parentheses 325 plus 41 divided by 60. Must close your parentheses. That is my angle in degrees. Then times pi and divide it by 180. And there's my answer, and I need to round again to 3 decimal places, so that's this position. The 2 is not going to round up that 4, so my answer is 5.684 radians. And one last thing I want to point out is I wrote radians on each of my answers for clarity. But technically, we don't have to do that, as if there are no units given on an angle, we know they are in radians.